Hello, hello. Hope you guys are doing well. Today is a difficult day trying to get stuff started and trying to uh just kind of get this day underway. It's a lot of other stuff going on, pretty much how that life works in general. Get too much stuff happening, you can't get nothing done. So we're gonna go ahead and make it happen regardless. I'm getting in here so I can say hello to you guys. So just give me just a second. And I gotta type in 1,000,001 freaking passwords just to make this thing work. Oh, no. Another way. Now I gotta see this. This is the 7/8 harness that we're working on now. I've done a full split feed setup right here with an EIA flange. Uh, are we getting in here to check out the live and look at you guys' comments? Kill that. Press that. Dismiss that again. And here we go. Not bad audio. I don't mind it. All right, and then let's check out YouTube. All right, so we're gonna go ahead and do the LC connector on this. Come on, go, buddy. I don't know how to make that work. There we go. Let's do this. Home on YouTube. Hey, it worked. Okay, cool. Now I gotta mute this one. All right, sorry guys. All right, what's up YouTube? What's up Facebook? And what's up Twitch? All right, hope you guys are doing well. Hey, waving a hand, 150. Hope you're doing well, Mr. John Wick. Let's get this 7/8 done. So now I'm going to go ahead and slide this up, slide that piece down, and so I can go ahead and do this end. So this end is the end that we're going to be working on. This end is complete. We're finished with this project. I don't know how much more we're going to do today after this, but because we're already getting a late start, but I think I'm going to go ahead and go a step further. But we'll cross that bridge when we come to it here in just a minute. So this is always tough to move these, especially after you've already tightened them up. Come on, you can do it. So I don't know if this is all in the shot. I'm sure it's not. There we go. Let me back up real quick. So I'm just sliding this zip tie down because I don't want to waste it. There we go. Oh, so close. Now I got this out. So now what I'm going to do is just pull this booger and tighten this back up. So whenever you're working with shipping materials, a lot of times it turns into a major pain in the neck when something loses its shape because you're trying to keep shipping costs down. So you want to keep stuff in some smaller packages. Now I could rewrap this again, uh, and have it even smaller, but the goal is not wasting all the effort working with what I've got. So Let's see. Because I've rewrapped my fair share of spools, and I just really don't want to have to keep doing that a bunch over and over again. So line this up. Put this right here. Let's zoom in real quick so you guys can see what's going on. Something like that will work, I think. All right. This is going to be kind of hard because of this bracket, but we'll see. So the goal here is get the bend out of the wire somewhat, at least to the best of your ability, where it's pretty straight. It don't have to be perfect, but just pretty straight. I do not need this jacket. It is not quite cold enough for this. So I think moving this around, yeah, this should be about in a good spot right where it's at. So get the jacket off and, say hello to you guys. Waving a hand, Philomena, Coop Dog, and Jay. Hope you guys are doing well. Let's check out Facebook and see what you guys are saying. All right. So this is what's called an LC connector right here. So if you look at it all complete into one piece, it looks like that. So this is just a larger connector for this large piece of coax. If you guys have seen smaller coax, that's a smaller connector, and that's a larger one. They both do the same thing, just one handles more power than the other. So today, what we're going to be doing is building this one. I'll turn that way, something like that. I think that probably should be pretty good. This is, can't be ousting the guy that owns it, but it's for a mobile base. Let's call it that way. It ain't mine. It's for a customer, but it's for a mobile base. Let's just say that much. All right, so let's get to work and start cutting. So the way I'll set this up is, of course, our center conductor goes here, but then we have to go ahead and measure for the body of this and this exterior connection right along this edge. That should be what I'm looking for, I believe. If this is not the right one, I'll check my, I got a baggie full of these, so I'll grab what I need if it's not the right one. So we've got a caliper. So I'll take our little caliper right here, and this will tell us what we need. What's up? I can say hello in the camera over there, or in the mirror over there. So YouTube, you guys got questions? Y'all want to know anything? If you'd like to know what this stuff is, feel free to ask. It don't hurt my feelings explaining it to you guys. So we'll do a plunge test, and we'll stop a little early. So 42 mil from top to end, but then we were going to do a simple 42 mil from there, start at 0 pretty much. And we got 5 mil there. So 5 mil there. I measure this. This is 2 mil. So that means we have 3 mil of overlap. So 42 mil takes us down to 37 mil with 5 mil off. And then add 2 mil, that puts us at 39 mil. So basically, pretty much 40 millimeters. So I'm going to cut it off at 40. Actually, I'm going to do a little less. I'm going to do like 38. Simply because I might have to do something pretty unique on this design. You guys that have seen me build LC connectors before know what I'm about to do, but the other guys, you might be surprised because it's definitely something unique. Yeah, y'all feel free to ask questions on YouTube. I don't really mind. It don't hurt my feelings. Yeah, man, shoot, get some. I've got some cheaper 7/8 too. I've got another manufacturer that actually two other ones that are cheaper. I've got one for $8 a foot, one for $6.50 a foot, and the other one is $5 a foot, and they're all 7/8. So kind of a pretty cool little bonus for you guys. Wonder if this will fit. No, it won't. I was just checking something. I'm going to do something a little bit extra for this gentleman because he's uh spent some money with me before. I want to do something nice for him if I can do it. So let's line this up. So, what do you guys think about this shot? Or would you guys rather be kind of like facing me where you can see what's going on? What is y'all's opinion? I'll show y'all that shot and then I'll kind of put y'all guys that way. That's another option. What do you guys think about that versus the first shot? Uh, and then I can try to move you guys somewhere else if you guys have another opinion. So tell me your opinions. I will listen. So this is not to cut this wire. This is just to do the initial, marking pretty much. So if this goes well, it doesn't always go well. It's just a guide. I just run around the wire itself. And if it's went well, it hits perfectly in the line on the other side. So basically it makes a perfect circle. It made it extremely close to a perfect circle. I guess I would have to say maybe like a 16th of a millimeter. It's just a hair outside the initial mark, but extremely happy with that. So I'm just going to strip this wire back. So it's got a pretty hefty jacket, so you have to cut in pretty deep. So any opinions, guys? What you guys think? Go back to Facebook and see what you guys think. Nobody has an opinion about the camera angle, so I'm gonna stick with the new one. Uh, Now, if you guys are checking this out on Twitch, I'm sorry, I'm not checking out chat right now. I will try to look back every once in a while, but YouTube and Facebook, I'm checking you guys out. So if you guys want to say anything, y'all feel free to say hello. Oh. And I need, well, I guess I could just use the same thing. That'll work. But, all right. So now here's where this work goes. You ready? You guys are going to be disappointed. Not really, but it'll be pretty interesting. Here we go. I'm going to use a different set of pliers just because those are all right, but they kind of grab weird. So let me find these right here. This will do quite a bit, that's for sure. 7/8, its power limit is around 15,000 in the HF range. There are guys that have exceeded that, but for a 24/7, 7-day operation, this is kind of what you're going to go for. So the LC connector is going to be the main power limit of this one right here. So you guys don't get too confused. This jacket has a specific outer diameter that I'm having to deal with. So what I do is I don't go into the corrugation itself. I just take the wire and flatten out the overall edge. So I've done this a few times with this smaller tool. and I'll show you guys how it works. I just started it with that. Do it kind of like this. Put that booger around. Tighten her up a little bit more. So I'm just running it on this roller and flattening it out. Then I move up further, or up higher, excuse me. And all that does kind of evens out all my high points. So this is probably one of the more difficult coax connectors to do in a general sense, because this is significantly more effort than what you should have to put forward on something like this. 104 Indiana, hope you're doing well, man. All right. So I just need to check and see how close to the 40 mil I was at before that I was trying to measure. Zero that booger up. Pretty dang close. So I got an extra 2 mil from that design. Let me get some. So this just keeps this O-ring from getting damaged as I'm putting it on, and then also, of course, helps it slide as I'm working with the rest of this material. So now we'll see how quickly this job goes. If everything went well, I did this absolutely perfect, then this will slide on and we won't have to do nothing. But generally that's not the case. So what ends up happening is I'll have to spread out these fingers on this specific connector, not every connector, but just this one specifically. Now I don't know what all you guys are doing on YouTube, but y'all feel free to say hello. It doesn't hurt my feelings. I do appreciate y'all guys checking this stuff out. But feel free to comment. Let me know what you guys think. So we're gonna go ahead and yeah, YouTube's been kind of wild lately. I've yet to figure it out, to be honest. All right, not in a bad way. It's a good thing for sure. I appreciate all you guys. So we're gonna just basically open these fingers up, like I just mentioned a while ago. So it doesn't really matter what tool I use. I like to use these if I can make it happen. Actually, I'm gonna do this backwards if it worked. There we go. So all I'm doing, sticking the pliers in here and just opening this up to where these fingers are no longer holding on super tight. As after I get them on, then I'll tighten up all the fingers and we'll get back to work. See, it's on. Our O-ring is pushed all the way down. The wire's connected pretty darn well. And now what we have to do is we have to kind of close this back up. So, like I said, this is 7/8 Helix. This is a type of coax. This is some high voltage wire. This is another type of coax over here. This is RG400. You guys got questions or want to know, feel free to ask. Back over here. What's up, Mud? Hope you're doing well, man. But questions are appreciated. You guys can feel free to ask anything you like. I really don't mind that stuff at all. A lot of guys kind of get really confused and don't understand that these lives are specifically for you guys to be able to ask questions. So I'll get new guys that just check out a video and be like, man, what the heck is he doing? But they don't never ask. So I can't never tell them anything. So feel free to ask. Like I said, especially YouTube guys just hanging out and checking out and seeing what's going on. a lot of these Facebook guys already know what I'm doing because they've seen me do it before. Um, all right. So all I'm doing is going to be holding this into its form right here. So I want these fingers to be closed while I'm building a flange. So if you've ever seen a pipe or whatever, say a gas line or something like that, you flare it out. That's what I'm doing to this connection. I'm flaring outward like that. You got to be careful because this is sharp right here. It can cut you. So just take it slow. Don't go super fast, and just make sure you're careful with what you're doing. Waving a hand, young blood. Hope you're doing well, man. Good evening. Yeah, I'll be seeing you in Joliet. You need to give me an address for the event for Joliet, or where I need to ship something for Joliet. And I'm gonna do something again this year too. So I probably want to get a little bit more proactive on it. And also, if you can, I don't know if they'll accept it this late or not. But I think it's Mean Queen who does the New Orleans. If you can, just if they're wanting to take any more donations, then give me some information so I can contact her too. So I want to try to help out all the clubs if I can. I see them at all the events, so and I never get to go there, so I'd at least like to help them out. All right, I already shipped out Hawaii's stuff. There's a if you're going to Hawaii here coming up, there is a piece of 393 with two UHF connectors on it sitting there waiting on you. See if you can win it. They have these clubs. They put these events on, and um, without our help and without our support and without us showing up, they wouldn't be putting them on. So feel free to make it. Hope you guys get a chance to be there. If not, there is a Joliet, Illinois one. That there's another event in Joliet, Illinois. There's another one in um, uh, where the heck is the other one at? Southern California somewhere. I don't remember the city. There's another one in North Carolina that's coming up. There's another one in Ohio. I think it's Cleveland, Ohio, is I believe the city. So if you guys get a chance to make it to any of them, feel free. That'll be fun. I'll also be posting up some Hamfest that's coming up at some point. I just have to get them all together and share them with you guys. So all right, that's how this looks. This is how this sets up. We're going to go ahead and cut it. We need to go ahead and make sure the back exterior of our shield is pushed back where we don't have to deal with any sort of our dielectric, preventing our connection on our flange. So all I do is just go to the inside and just start pushing the dielectric down. It's foam polyethylene. There's a little bit every once in a while of shavings that get in there just from like doing the flare. Uh, but all you have to do, get a pair of pliers, pull them out, or just use a little bit of forced air. You can use a air compressor if you want, get a little bit more pressure on it. But this works just fine. All right, so the fitting's flared. We're good to go. And now what we need to do is get our center connector, our bullet, put in. So here we go. Hey, heck yeah, man. Appreciate you. Thank you. All right. So I'm trying my best I'm gonna try my best to kind of really advocate for a lot of the clubs this year, so you guys will kind of be able to see these events. I'm gonna go to them. I'm gonna show you guys what's going on. I'm gonna let you guys see what you guys are missing, and I'm gonna convince you guys to go to the nearest one near you. And we are gonna uh, and just encourage this. It's just a fun thing. It's enjoyable. These guys are some of the coolest guys you'll meet. They're super good. They're super hospitable. Young Bud right here in, on Facebook is, has been very, very good. Always been running an event for years and definitely helped a lot of guys and supported a lot of people and, kept the hobby going for a long time for sure. So do what you can and show up. I know Mike had messaged me wanting to know where the one in Ohio was. But like I said, see if y'all can try to make the Illinois one. If you can, Todd, I'm not sure if you'll be able to make it or not, but I know you're over there in near Indiana. So if you can get a chance to make Joliet, I'll be able to say hello to you over there. I posted the events on my page, so you guys will be able to check it out. If you YouTube guys would like to see stuff like that and kind of want to get into this stuff, then feel free to ask about it and we can kind of talk about it. Um, but mostly this is for the guys that are super deep into the hobby. And it's, kind of a specialized event, but absolutely is welcome to anybody who wants to learn about it. But it may be confusing for some of you guys. Um, but for the guys who've been on this page for quite some time, they'll know well aware of what's going on. But I got quite a few newcomers on YouTube hopping in, checking this stuff out. So we're going to go ahead and get a torch. So solder melts at a bit over 400 degrees. What? So the way I line this up is I have to get this while it's nice and hot. If it doesn't work, that's easy enough for me to fix later on. But I try to go ahead and get everything started and lined up. Well, I need to do something with a piece of wood. I got something. Yeah. We did it. That was these are usually I mean, they're difficult. They're always difficult. Every one of these are a pain in the freaking neck. But, we successfully got that one a significant amount sooner than what has happened in the past. So super happy about that. I always have to fiddle with these afterward and be like, oh yeah, I'll end the live. And then like 30 minutes later, I'm finally done with it, trying to get it threaded on and lined up. It hadn't beat me yet though. YouTube, you got questions? You guys feel free to ask. I know there's a lot of you in here hanging out, so ask anything you'd like. Slide this further down. So I have to start. We'll see. Now, I did speak a little soon, so we'll see if I'm sticking a foot in my mouth here in just a moment. So, we'll go from here. Heck yeah, man. Sure, for sure. We got to keep the hobby alive. So, hang on a second. Let me not do this. I'm going this way. We're cutting So here's the part that scares a lot of guys. Oh no, I just put this together. How do I know if it stays connected? Do your absolute best to pull it this way. Pull it off. If you can pull it off at all, then it wasn't put on correctly to begin with. So luckily we're good. If it pulled off, I would have cried. We would have started over and we would have just got to work. That's just how it works, guys. You don't get worried about it. Don't get scared about it. This is the most important aspect to go ahead and make sure it's on here properly to begin with. So that is an LC connector right there. And then the DIN connector, or excuse me, the EIA connector is right there. This is a really cool EIA setup. You guys see how it's done. That's for a custom drop down bracket right there. And we'll go back over to this setup right here. But yeah, that's how this sets up. This harness is complete for this customer. And, I guess we will do from here. We'll go ahead and do, what do you guys want to see? You want you guys to see a piece of RG393 or would you guys like to see something else? This one's a coaxial cable. So if you look at the center, the way it works is you got a center conductor and you got a very large foam dielectric and then you got a shield. So it's the same as some of these smaller coaxes, kind of like this right here. But it's significantly larger and it also uses a, let me show you the shield. Let's just cut this out real quick and let you guys see. So, but yeah, if you've seen like your RG6, your cable coming in the side of your house or your, just all kinds of other stuff, it's the same stuff. So let me just cut this open real quick so you guys can see. So let's pull this off right here. So if you look, well, you guys got to see a while ago, but for the guys who didn't, let's show the rest of you guys. See the corrugation? So that's a corrugated shield right there. If you've look at, say, some of the other cable, say this is the remnants of a piece of RG393. So RG393 has a Teflon dielectric. That's what this center conductor is right here. And then it has a shield. So we can push that shield out like this right here. I'll just pull it out. My needle noser. There you go. That is the shield. That shield will go over top of this dielectric and it's a braided shield. This is a solid shield. So that's, it's a hollow center conductor. This is a stranded center conductor. The reason that you don't have a solid center conductor right here is because it doesn't matter. It's for core strength for sure, but once you get beyond a certain size and core size, then it doesn't matter about the center. It's just wasted space. So at any sort of higher frequency than just like normal, like electrical energy, like on the power lines, like your 60 hertz, you start to get something called skin effect. Skin effect is how deep that RF can penetrate through a substance. So let's say I had this wire over here. So if I zoom in real close, there's some 4-aught wire right there. So that's a bunch of 4-aught. See all those small strands? When you get into higher frequency, all along the outside surface is all that's used. Everything in the middle is just wasted space. So yeah, that's kind of a little overview for the guys that may or may not know. What Bill Gates? Now, this is a type of communications equipment right here. This is a type of a very large coax. I work on a lot of wiring harnesses for a living, and build custom brackets, custom accessories. This is some high voltage wire right here. This is good for 25,000 volts. This is a high voltage safety stick right here. This is a type of coax connector here, just significantly larger than most. So it's just some pretty cool stuff. It's basically just RF frequency. All right, so Yeah, for sure. It's definitely it's not your small stuff. It's usually so if you guys have ever seen cell phone towers, a lot of those AT&T, Verizon, stuff like that, they will have coax like that because they run up thousands of feet. So when you run that long of a length, you have something called attenuation. Attenuation is the amount of loss that a particular coax has over a specific length. Lay the hand, Jacob. Hope you're doing well. Hey, Jacob, what's your handle again? I'm sorry, I don't know. I don't remember crap, man. I try to. My memory's like a fart. But let's go ahead and wrap this up. This is going to get packed up and shipped off. I think it's going to the northeast corner. That is the first harness. I just need to put it inside here, something like that. And then, of course, this side over here, we'll spin it around. This is the custom bracket that it's getting set up with right here. And we'll go ahead and set it right inside there, something like that. So that'll get packed off and shipped. It's ready to go. The minimum bend radius on this is fine, but you don't want to bend much tighter than this bend radius right here. Probably about a little tighter. I think a 9 inch is the minimum bend radius. But you typically, if I'm recommending somebody, it's going to be about 36 inches is what I would say for a repeated bend radius. This is just for shipping purposes. The rest of their equipment, of course, is over here. They're doing some HV wire. They're doing a coax bracket right here. And then, of course, they've got some material to mount it on their boom. So I'm going to put this out of the way. I want to grab some smaller coax, some RG393, and I'll show you the Teflon coax. This is used in aircraft stuff quite often. So I'll put an example over here. That's what RG393 looks like. But I'm going to go ahead and grab a spool and we'll go ahead and start wrapping it off. So, I got a customer ordered this, and we got to go ahead and run some wire. This wire has an extremely low friction coefficient, so it's just a pain in the neck just putting it on a spool by itself because it just unspools itself. Super low friction coefficient means it's super easy to slide. So good for running it behind, like in aircraft, behind body panels and things like that, in situations where you need to have a wire that's not going to get cut by sharp surfaces. 616 in the Keystone State. I will try to remember that, Jake. Appreciate you, man. What was that GTO 15? I'm not quite sure what GTO 15 is. I apologize. Oh, no, not GTO 15. I know what you're talking about. This is a type of reinforced fiberglass, is what this stuff is. It's high voltage board. So there's a makeup for all of them. There's like FRP plastic, there's GPO3, there's a bunch of different style stuff. But yeah, there's a lot of it. I got to get my measuring tape. I've got one right here. Believe it or not, I got the little bulk wrap measuring tape, a Milwaukee, and a little Stanley right here. And all of them are shorter just for specific reasons. But the one I like the most is the flimsiest one, believe it or not. It just makes life simpler, especially when you got a small wire that you're trying to measure off and see what it's doing. So, so we're just measuring this off for a spool for a customer. So he's getting a small short jumper done. And that measuring tape just kind of flexes around and moves pretty easily. So it makes my life easy. I use this quite often. Just a simple little cutter right there. There you go. Let's get this spool out of the way. So if you guys are not familiar with spooling up wire, it's not super hard. This just kind of takes a little bit of work. You'll have to put a couple more zip ties on it than normal, just because it tries to slide right out of your hand. But if you guys have ever dealt with Teflon, it's a non-stick surface. It's very good for super high heat. It's good for all kinds of stuff. Not really good to eat near, so don't be doing it on your food. But it's excellent and has hydrophobic properties. It has high voltage dielectric strength properties. It's got a very low friction coefficient. It's got a very high temperature rating. Like there's a lot of stuff it's good for. So Let's put a few zip ties on this real quick. So I do these tutorial videos all the time. So anybody on YouTube that found that you like this stuff, you feel free to hop in here and check them out. I'm trying to get to 1,000, but actually it doesn't matter anymore. I was trying to get to 1,000 people on here so that I could go live on my phone, but I figured out a way to get around it. So it actually worked out just fine. Um, I've been doing Facebook for a long, long time, but YouTube, I just made a little nostalgia page, but I finally just decided let's go ahead and just start doing my lives there too. I've been doing lives for a long time on some other platforms, but YouTube is another area. A lot of guys don't have Facebook or don't have Twitch and stuff like that. So me hopping out here on YouTube, you guys can check it out and see what's going on. So I'm going to do a smaller connector on this. This is a UHF connector, or also known as a PL269. So it looks like this right here. We'll zoom in closer on this shot and see if you guys like this angle better. So down we go. I'm going to come in nice and close to this, and I'll just get to work building it. My bench looks kind of nasty, so let's take all that trash we just had on there and clear it off. So, the way this works is you have a center conductor and you have a dielectric or a insulator of some sort, and then you have a body. The body is where your shield will go, and the center conductor is where your, or excuse me, the center is where your center conductor will go. This is just a ring just to help it lock into place. So, there's, of course, the center is going to go up through here. Then the dielectric is going to stop pretty much flush with this piece right here. I've done a few measurements with a caliper before, and pretty much if you look right at this knurling right here, I can zoom in if you guys want me to. That's where it stops. So that's what I do all my measurements at. I can be more precise with a caliper, but for argument's sake, I'm not going to, or for speed's sake, really. RG393, like I said, is a double shielded wire, so it runs two separate braids, and they are a silver plated copper braid, and then it runs a Teflon dielectric and a fluorinated ethylene propylene exterior jacket. Those are types of what's called fluoropolymers. This means they do very good things at certain parts of the jobs. So pull the center conductor off. There you go. Excuse me, pull the dielectric and the shield off. Leave the center conductor on. All right, let me hop in over here. Mud Duck, hope you're doing well. Junior 22. Gary, hope you're doing well from the Sandpile 305. Too short, have to get a new one. Or can I add on? You can add on. The insertion loss on coax is not as bad as what you would think. So you could add on if you already have some 7/8. So don't feel like you're just stuck and dead in the water, because your length ran short. A lot of guys do like to go when they're spending that kind of money, to go ahead and, just go a solid length. But, if it's a budget thing, you can absolutely operate within budget and just, run another jumper. So, the only thing that kind of gets expensive when you start doing jumpers is basically the connectors, the terminations. When you get into the bigger wire, terminations are a bigger expense. So there's a little bit of metal right here. So if you look really closely, I'm going to zoom in real quick on the end of this. See if you guys can see it. Right on the end of that, it's just a little piece of metal. It doesn't, yeah, it's right. No, it fell off just now. I'll grab another one. See on the end of that little silver piece right there? That's just a shaving. That decreases your dielectric strength on whatever material you're using, because all it does is provide a path of lower resistance somewhere else. And it will allow it to prematurely fail. So always be safe when you're putting the stuff together. All right. You guys got some more questions on YouTube? Feel free to ask. I know there's a lot of you guys in here hanging out, checking it out. Um, this is another type of coaxial again. The bigger 7/8 is pretty cool to see. The smaller stuff, this actually is, extremely high voltage, or extremely good dielectric strength. So as far as actual fail from arc over, short of a termination problem or an issue at the connectors, it's just doesn't happen really. The wire will get hot, but it won't actually arc over. So pretty neat. It's got some really cool properties to it. In the communications world, as far as for the guys that need smaller stuff, it's a very cool alternative to having to run something this large right here. So let's zoom in so you guys can see a little better. Maybe you guys will like it more. I don't know. If you guys would rather just have me back off on the camera, let me know. But I'm going to show you guys how to solder now. So this is a soldering iron right here. It's holds a temperature usually above 600 degrees for the most part. Depends on what you're soldering, on what your temperature is going to be for the most part. Um, this is a rosin core solder. So what you do is just heat it up and you'll watch the solder wick in. So you're not actually adding solder to the actual iron itself. You're adding it to the source. So you can see it kind of just suck into that source. And there we go. That is a low heat weld. So if you was to if you're interested in like TIG welding, the concept is very similar. All right, there you go. She's nice and bonded on the center. So now I have to bond the shield. So we have to go a little bit unorthodox because an 80-watt pencil is not necessarily going to bond to the shield, not without extreme heat. What's 393 rated for up to mobile use? According to the manufacturer, about 15,000 at lower HF. Anything above HF, of course, the rating goes down because the higher the frequency it goes, the less it can handle. So you see how that bubbles right there? So what you do is it's not hot enough to actually bond, so it'll just keep bubbling up. So what you do is you just preheat it. You can't do that with every wire. You can do that with this wire though. This is a, like I said, very high heat rated. I mean, just the exterior jacket's still good for 500 plus degrees, and that's for continuous. So see it suck in? Just literally wicked right on in. So that tells me I'm up to temperature. From there, I just start adding some solder. Stuck her on in. So what you want to do is you want to kind of just seal this connection off completely with solder. You want to bond it all the way up to the edge of the shield. You're not just trying to bond the solder to the body, or excuse me, the shield to the body. You're trying to actually kind of close up that connection too, because it is an open connection to the shield. See if this is a good angle. It's not too bad. Sorry guys, it's kind of hard to hold this spot. So forgive me if the angle's not perfect. I'm doing this all kind of free-handed and balancing it on my hand, on the desk at least. Excuse me. Alrighty. Next, let's do this one down here. I need to do like an X marks the spot to make sure I'm lined up right, but I think we're doing pretty good. You guys feel free to comment on YouTube if y'all want to know what RG393 is, if y'all want to know what coax is, what it does, and stuff like that. Feel free to ask. Questions are welcome. They're not. Don't feel stupid. There's no such thing as a stupid question because I would. I'd rather a lot more people get to know what I'm doing than it just to die out and nobody know anything about it. So it's not going to die out anytime soon, but probably in the next 20 or 30 years, if more people don't get interested, then it definitely could get severely, a lot severely smaller, or I don't know what you say, significantly smaller. Sorry. Had to come up with better words. It's late, guys. Right. So this cable is basically an RF patch cable. It allows signal to transfer from point A to point B. This is good for up to the gigahertz range. So any sort of RF, coax for anything, I generally build for the public. So I'm building and shipping this out to individuals all over the country. Uh, it can be used in aircraft application. It can be used in any sort of communications application. It can be used in HF. It can be used in VHF, UHF, all of it. This is a very universal cable. It's typically used in aircraft for a lot of military use and stuff like that, and even for like just higher end aerospace applications and stuff. Um, so that's what this stuff is for. Uh, now it can be multi-purpose for lots of other things, but that's what it is. I have another order, and let me pull this order up. Give me just 1 second. So, like I said, I ship this stuff all out all over the country. This is stuff like bird meters. If you look up here, this is basically an RF reading device. So what it does is it can actually read, uh, pretty much any sort of power at like HF frequency. That's 2 to 30 megahertz. They make them, some extra ones. Basically, this is just a directional coupler that senses power one direction or another. That'll do 100 to 250 megahertz. Um, these right here are typically used in like old broadcast transmitters and stuff like that. You'll see them on the FM broadcast and AM broadcast kind of stuff. That's where that equipment comes from. This is test equipment right here. Basically this will do 7 megahertz to 4 gigahertz. Same for the device above. And then the device down here will do up to 3 gigahertz. That's a network analyzer that allows me to take, and kind of run impedance, measurements on, coax, on RF circuits and lots of other things. But basically just for communications for RF. Your phone uses RF, your Wi-Fi uses RF, your AM FM radio uses RF. There's lots of RF in the world for sure. So let me type this in real quick. And any more questions, you guys feel free to ask. Because, like I said, I really enjoy kind of teaching people about stuff like this because I don't want to make stuff so complicated where people just can't understand it. This customer right here, what did he order? Let me look real quick. Oh, this one ordered something special. All right, so I've got another one of these to do, but I've got DIN connectors on it, and it's not going to be available until probably next week. So I've got to do it. I've also got a couple more things that I've got to get done. But for the most part, what time is it right now? We are out of time. So there's lots of cool stuff I can show you guys. This is a socket right here. It's for a device that produces RF. Of course, this is some of the larger connectors right here, how big they can get. They can get significantly smaller. An RF connector here. This is also an RF connector right here. It's used for significantly smaller application than what something like this would be used for. So, both of them do the same function, but they have different power capabilities and also frequency characteristics. But yeah, I appreciate you guys hanging out. I know there's a ton of you guys on YouTube and a ton of you. Well, I mean, I got a bunch of my regulars on Facebook. But I do apologize. There's not much more to show you guys tonight, but come back later and come check it out. Feel free to subscribe and check out and see what I'm doing. Appreciate all you guys. Thanks for watching, and I will catch you guys later. Probably I'll be back live. Should be Monday. And then of course we'll be in Hawaii, on the 7th to the 9th. I may do a couple videos on that, explaining about like different situations with, different RF applications there. But yeah, this one's getting shipped out. This is some high voltage wire, and these are the brackets that's going to be set up for that customer there. You guys got any questions? Message me anytime. check out further videos. And like I said, feel free to subscribe and check it out. I will catch you guys later. Y'all have an excellent evening. Mr. Radio, jumpers, I've got them on my website. You can order them by link. So, let me see if I have a way to do this. So if you go right here, this will take you directly to my website. It's dwinsrsupply.com. So it'll have what's called how to order. So you can order specific links on specific types of coax with whatever connector that you want. It's a little bit complicated somewhat. You have to order one, the coax, two, the ends that you want, the terminations that you want, and three, the labor if you want me to put the ends on. For like small coax like this, it's $10 an end to put them on. Bigger, $15 to put an end on. And I think this one's $40 an end to put them on. I sell individual parts. I sell the wire by the foot, or I actually sell completed harnesses. So anything you'd like to do, feel free to check out the website. It's dwinsrfsupply.com. And you can make any order you'd like. If you're mono banded, I can set it for velocity factor. If you're multi banded, I can set it for, I can just do whatever length you request. So, got any questions? Feel free to message me anytime. Appreciate you guys. Thanks for hanging out, and I will catch you guys later. Hey, no problem, man. Appreciate you. All right. See y'all.